Right, solving equations that have one variable, usually pretty simple process. What you're looking to do is you're looking to combine all your like terms, and then you're going to isolate the variable. So a basic form of this looks like this problem right here. And so here you have x terms on both sides of the equation. So if you move them all to one side, so let's say we subtract 5x from both sides and subtract 9x from both sides. So here you get 16 minus 5x is 11x, minus 9x is 2x. And then we're going to move all the constants over to the same side as well. So if we subtract 32 from both sides, we get 36 is equal to 4. And then isolate your variable, divide both sides by 2, and you get your x value to be 2. Now, you can also use the Desmos calculator for this. So here's an example of the Desmos calculator. If you are doing this on a calculator, what you would do is just set each side of the equation equal to y. So you're going to write two equations, y equals 16x plus 32, the left side. And then you're going to write a second equation, y equals 5x plus 36 plus 9x. So if we type both of those equations in, so here's y equals 16x plus 32, and here's y equals, and you can combine these mentally too if you want, or you can just write them as they are. And then you'll see here when you look on the graph at where they intersect each other. So if we take those two lines that are sketched here and we find the intersection. So I click right on them and it gives me an intersection point, and I see the intersection point gives me the solution to 64. So 2 is the x coordinate, and that would be your answer. Right, the other examples that I have here are ones where it's asking you to solve for a specific form. It's not just saying find x. You're actually, it's x times something or added or subtracted to something. And so for these, it's somewhat unique to the SAT. And problems like this, what you're looking to do is you're looking to create this form. And you're going to do that by using more direct calculations. So here's what I mean by that. So here, if you know that x equals 27 and you want to solve for x plus 19, now this one's a pretty basic one, right? You could just substitute the 27 in here, and when you calculate this, 27 plus 19 is 46. But what you can also do is you can take the equation they give you, and in order to directly create this form, you would add 19 to both sides. So if you took x equals 27 and you manipulate it by getting it into the form you're looking for, x plus 19, you would do that by adding 19 to both sides, and then that gives you your answer, 46. So for something like this next problem down below, if you are looking for the form 6x, so again, it's not just asking you to solve for x, we'll simplify what we have. When we take our 3x plus 3x, we get 6x over 2 is equal to 33. Now, instead of trying to actually just solve for x and then plug that back in, we have the direct form 6x. So we want to isolate this in order to create 6x on the left side. We're just going to multiply both sides by 2, and that gives us 6x is equal to 66. And so we directly create our solution just by finding the direct calculations. All right, so let's look at these like bottom examples here. So if we want to find the equation or the expression for 2t, what we can do is we can start to simplify what we have, but we want to create this form. We want to find 2t on one side of the equation. So if I get rid of my grouping symbols and combine my like terms, here distribute the 3, I get 6t minus 24 plus t is equal to 3 plus 5t. So if we subtract 5t from both sides, I get t plus t is 2t. And if I add 24 to both sides, I get is equal to 3 plus 24, which is 27. And again, I don't need to solve for t. I need to isolate and solve for this direct form 2t, which I have, and I see that 2t is equivalent to 27, and so that would be my solution. Okay, go to this next example here, and you're looking for the form 2 over x. Well, when I look at the given equation, I have the form x over 2, so the easiest way to create the form 2 over x from this given equation is to just invert both sides. So if I'm taking and dividing both sides, or inverting both of these sides, and so inverting the left side, I get 2 over x. Inverting the right side, I get 1 over 5. Here's the form I'm looking for, and its equivalent is 1/5. You can also write it as the decimal form 0.2, but fraction form is usually the easiest to enter. Right, this final example here, you're asked to get the form of 8 plus 2x from the given form 4 plus x. So once again, you could solve for x, right? You could subtract 4 from both sides. You get x is equal to 10 minus 4, or 6. And then you can write it as 8 plus 2 times 6. Well, 2 times 6 is 12 times 8, and that would give you your answer, 20. Or what you can do is just use a direct calculation to say, if I took 4 plus x, I would need to double it to get the form 8 plus 2x. So if I double both sides to keep the equation balanced, I get 8 plus 2x is equal to 10 times 2, which is 20. And so often that gives you a slightly more direct solution that you're looking for. Right, the other type of answers that you're going to see when you're dealing with equations with one variable in the SAT are ones where you have either many solutions or no solutions. So many solutions, what's going to happen is both sides of the equation completely cancel out. And you can think of this as they're either going to be identical or they cancel out. So what you will wind up with is you wind up with a side of your equation where you get 0 equals 0, or 5 equals 5, or x equals x. Both sides are going to be the exact same thing, and this is going to be always true. And if you have it as always true, then that means there's going to be infinitely many solutions. Okay, so if you're trying to get infinitely many solutions or finding a value for that, what you need to do is make sure both sides are exactly equal to each other. Now, contrary to that is a no solution. Here you get both sides give numerical values that are not the same. So it gives you a false statement. So here you would have something like 0 equals 5, or you might have negative 3 equals 3. If you have a statement that is not true, so those are not possible, they're false statements, that means that there would be no solution. Okay, so if we look at the examples here, so here you're told if you have exactly one solution, what that means is it's impossible for these to be the exact same. So the only thing that k could not be would be the form where each side would equal each other. And so if k were 7, then you would have many solutions. That's what you're looking for. If there's exactly one solution, then there cannot be many solutions. And so 7 is going to be the answer. In this next example down here, you're looking for no solutions. So again, a no solution, each side of the equation is going to be different values, but it does mean that the expressions for x have to be the same. So if we distribute these, the 3 through, we get 3kx minus 3n is equal to negative 33 over 13x minus 34 over 15. And so in order for this to be no solution, the x's have to completely cancel, or again, be exactly the same thing. And so what we need to find is what's the number that we can plug in for k, so that 3kx is equivalent to negative 33 over 13x. And so here, if you just solve for k, so we divide by x, those cancel. We also divide by 3, but when you take a fraction and divide by 3, it's usually easier to think of it as multiplying by the reciprocal. So if we multiply both sides by 1/3, we get k is equal to 3 goes into 33/11, so you get -11/13 as your answer. So the SAT on the fill-ins or the grid-in answers can now have negative numbers as well. Right, and then the final question asks you to identify how many solutions you'll have. So when you're looking at this, again, if both sides are identical, you have many solutions, or if they are if they are not equal, then there's no solutions, and if you get x equals some number, then you have one solution. So this is going to be x equals some number for its form. And so what you're doing here is you wind up expanding each side of your equation, compare the two sides. So if I distribute the 3 through here, I get -27x plus 21 plus 8. Continue to kind of simplify what I have. 21 plus 8 is 29. And so when I look at this, I have the left side versus this right side. The x's are going to cancel out, but I get 29 is equal to 26, which is impossible. Therefore, that's going to have no solution. In the second example here, if I distribute the -6 and compare both sides, I get positive 24x plus 42 plus 6, and that's equal to 25x plus 53. So here notice that when I combine, I'm getting subtract the 24x from both sides. That leaves me x, subtract 53 from both sides, and I'm going to get x is equal to -5, which is one solution. This gives me an actual numerical value set equal to my variable. In the final example here, again, when I combine my sides, or combine the terms on my left side here, I expand out. -2 times 4x is -8x, -2 minus 3. I get -8x minus 5. We'll notice that those are exactly the same thing. So they are going to cancel out and wind up giving you 0 equals 0, and that indicates that you have infinitely many solutions.